Hello student, now this is the miscellaneous exercise 2A. I am explaining all the examples in a very simple language in this video, and I hope that you will understood all the problems whatever that I am explaining. And at the same time I am teaching on an academy platform वर मी शिकवत आहे. M1 आणि M2 12वीसाठी लाईव्ह लेक्चर्स असतात, त्यामध्ये प्लस लेक्चर्स अँड स्पेशल लेक्चर्स असतात. तर त्याचं जर तुम्हाला सबस्क्रिप्शन हवं असेल तर या माझ्या छोट्या व्हिडिओ नंतर काही पॉवर पॉइंट स्लाइड्स तुम्हाला बघायला मिळतील, आणि ते जर तुम्हाला आवडलं तर निश्चितच तुम्ही ते सबस्क्राईब करा, त्याचं सबस्क्रिप्शन घ्या तुम्ही, आणि माझा कोड म्हणजे वसंत सर हा जर कोड तुम्ही वापरला तर तुम्हाला निश्चितच त्यामध्ये डिस्काउंट मिळेल. त्याचबरोबर डिस्क्रिप्शन बॉक्समध्ये मी अनअकॅडमीच्या लिंक दिलेल्या आहेत, त्याचे फ्री क्लासेस तुम्हाला माझे बघता येतील. अनअकॅडमी प्लस सबस्क्रिप्शन मास्टर बॅच फॉर MST CET 2021. Learn from top educator of MST CET for the preparation. Okay. In-depth analysis of the topics. प्रत्येक टॉपिक्स हे डिटेल मध्ये तुम्हाला शिकवलं जाईल. Dedicated doubt clearing session, and these batches are starting from the 4th of January. You can enroll now. आणि तुम्हाला जर त्याचं सबस्क्रिप्शन हवं असेल, त्यामध्ये डिस्काउंट हवा असेल तर इथे माझा प्रोमो कोड वापरा तुम्ही, तो दॅट इज वसंत सर म्हणून हा. नेक्स्ट, जर these are the benefits for the plus subscription. That is everything under single plus subscription. Next, the best plan for MST CET 2021 aspirant for the 12 month, for the 6 month. Okay, new batches starts every Monday. Okay, you can use this promo code. Again, these are the top educators. सर्व तुम्हाला डिटेल मध्ये शिकवलं जाईल. त्यामध्ये बोर्डाच्या एक्झामची प्रॅक्टिस, त्याचबरोबर सीईटीची देखील प्रॅक्टिस केली जाईल. नेक्स्ट इज टेस्ट सिरीज इज ऑल्सो देअर, an academic test series. Next, how to attempt the test series आहे ते दिलेलं आहे, आणि हा जर तुम्ही प्रोमो कोड माझा वापरला तर निश्चितच तुम्हाला त्यामध्ये डिस्काउंट मिळेल. डिस्क्रिप्शन बॉक्स मध्ये देखील लिंक दिली आहे अनअकॅडमीच्या फ्री क्लासेसच्या. निश्चितच तुम्ही ती लिंक बघा आणि त्यावरचे माझे व्हिडिओ बघा. निश्चितच तुम्हाला परीक्षेसाठी, 12वीच्या बोर्डाच्या परीक्षेसाठी आणि त्याचबरोबर MST CET साठी देखील तुम्हाला त्याचा फायदा होईल. फाइंड द इनवर्स ऑफ A cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1 by elementary row transformation. Now the solution, here we will write the determinant of A is equals to cos theta minus sin theta 0, sin theta cos theta 0, and here is a 0, 0, 1. Now we will evaluate this. That is equals to cos theta in bracket cos theta into 1, here is a cos theta, minus 0. Next, that minus and minus will become plus, minus sin theta, here is a minus sin theta, sin theta into 1 is a sin theta, 0 into 0, that is 0, and overall last is a 0 due to this 0. Therefore cos square theta plus sine square theta, that is equals to 1 and which is not equals to 0. Here, therefore, A inverse exists. Okay. Now consider A into A inverse, that is equals to I. Therefore, here we will write A, here is it, what is it? That is cos theta minus sin theta 0. 0. Next is sin theta cos theta 0, and here is 0, 0, 1 into A inverse, that is equals to 1, 0, and next is a 0, 0, 1. Okay. Now the first operation, that is by cos theta into R1, we get here we will multiply the first row, that is by cos theta, and second row with the sin theta, then addition of that you will get here 1. Therefore, we get here cos square theta minus sin theta into cos theta, last is 0. Next is a sin theta cos theta 0, 0, 0, 1 into A inverse. Here is multiplied with R1, that is the cos theta. Here is a cos theta. Next operation is a by R1 plus sin theta into R2. Then here is R1 plus sin theta into R2. Then here you will get cos square theta plus sin square theta, and here is a minus cos theta, sin theta into cos theta plus sin theta into cos theta minus sin theta into cos theta plus cos theta into sin theta gives a 0. Second row, sin theta cos theta, here is a 0, and last is a 0, 0, 1 into A inverse, and on this side, that is cos theta. Okay, next is a sin theta, that is 1 into sin theta, 0 plus sin theta, that is sin theta, and last is here is a 0, Next is the 0, 1, 0. Okay. By the next operation, there is a, we write here 1, 0, 0. Here is a sin theta, cos theta, 0, 0, 0, 1 into A inverse. Here is cos theta, sin theta, 0, 0, 1, 0. Okay. Now by the next operation, that is R2 minus sin theta into theta into R1. Then you will get here 1, 0, 0, 0. Here is a cos theta and 0. Okay. 0, 0, 1 into A inverse. Here is a cos theta into sin theta 0. Next is a R2 minus sin theta into R1. That is 0 minus sin theta into cos theta. Therefore, I will write here sin theta into cos theta. Next is 1. Here is a 1 minus sin theta into sin theta. That is a sin square theta. That is 1 minus sin square theta. That is nothing but here is a cos square theta. And last is 0 as it is. The last row is as it is. Okay. Now make this cos theta as 1. Therefore, by 1 upon cos theta into R2. Therefore, here you will get 1, 0, 0, 0, 1, 0, 0, 0, 1 into A inverse, and here is a cos theta sin theta 0. 1 upon cos theta into R2, that is minus sin theta into cos theta into 1 upon cos theta. That cos will get cancelled, and here you will get minus sin theta. Okay, here is a cos square theta into 1 upon cos theta. Means what? Only cos theta, and last is 0. The remaining elements are as it is. Okay, therefore this is the identity, and hence A inverse is equals to cos theta sin theta 0. Next is minus sin theta cos theta 0, 0, 0, 1. Okay, this will be A inverse. See this here. By elementary row transformation. I will apply here the column transformation. Now by the column transformation, consider A inverse into A, that is equals to I. Therefore, A inverse into, here is a matrix, cos theta minus sin theta 0, sin theta cos theta 0 and 0, 0, 1 is equals to identity matrix 1, 0, 0, 0, 1, 0. Next is a 0, 0, 1. Okay. Now by the first operation, that is by, first we'll multiply the first column by cos theta into C1. Okay, cos theta into C1. Therefore, here is A inverse cos square theta sin theta into cos theta, last is 0, minus sin theta cos theta 0, 0, 0, 1, and on this side that is multiplied with cos theta. It is 0, 1, 0, 0, 0, 1. Okay. Now the next operation is, that is by C1 minus, okay, C1 minus sin theta into C2 we get. Therefore, A inverse in bracket. If we add these elements, then here you will get 1 and sin theta into cos theta, here is a 0 and last will be 0, minus sin theta cos theta, and here is 0, 0, 0, 1. That is the first. C1 minus sin theta into C2, that is cos theta. Okay, overall here is only the cos theta. That is a 0 into sin theta, that is 0. Next is 0 minus sin theta, therefore here is a minus sin theta. Last is 0, again 0, 1, 0, here is a 0, 0, 1. Okay, this is the A inverse into 1 minus sin theta, 0, 0 cos theta, 0, 0, 0, 1. Now the next operation is a Now by that is a C2 plus C1 into sine theta, we get here is A inverse 1 0 0, next is 0, next is cos theta, here is a 0 0 0 1, and to the right hand side C2 plus C1 into sine theta, keep this C1 as it is, which is the cos theta minus sine theta 0. C2 plus C1, here is a C2 plus C1 into sine theta, then we'll get cos theta minus sine theta and 0. What about the next? Here is C2 means 0 plus C1 into sine theta, that is 0 plus sine theta into cos theta. Next is 1 minus sine square theta, it's a cos square theta, and last is 0, and here is a column 0 0 1. Okay, now by the operation 1 upon cos theta into C2, then here you will get 1 0 0 0 1 0 0 0 1 divided by the cos theta to the second column. First column, now here the first column is as it is, therefore here is a cos theta minus sine theta 0, sine theta cos theta 0 0 0 1. Okay, now this is the inverse of the matrix, therefore A inverse is equals to cos theta sine theta 0 minus sine theta cos theta 0 0 0 1. This is the A inverse. Now next example is, if A is a matrix that is a 2 3 1 2, B matrix is 1 0 3 1, find AB and AB inverse. Verify that AB inverse is equals to B inverse A inverse. Okay, now let us, AB is equals to, first of all we'll find out AB. Here is a 2 3 1 2. B is a 1 0 3 1. Now their product, first row first column, here you will get 2 plus 9, that is equals to 11. 2 into 1, 3 into 3, 2 into 1 is 2, 3 into 3 is 9, 2 plus 9, that is 11 here. Next is first row second column, 2 into 0 is 0, 3 into 1, this is the 3. Next is second row first column, 1 into 1, that is 1, 2 into 3, 6, 6 plus 1, that is a 7. Second row second column, 1 into 0 is 0, 1 into 2, that is equals to 2, and this is the AB matrix. Okay, now next I will write here again AB. Here is a, this is our first answer, that is 11 3 7 2. Okay, Now next we want to find out determinant of a inverse of AB. Therefore we will find out here is a AB. Next is we want to find out inverse of AB. Therefore here we will find out the determinant of AB. Okay, and here is the AB, determinant of AB, that is equals to 11, 3, 7, 2. Now 11 into 2, that is the 22. 7 into 3, 21, and that is equals to 1, which is not equals to 0. Therefore, we'll say that AB inverse exists. AB inverse exists. Now we'll find out the inverse of a matrix. Now that is the AB into AB inverse, and that's equals to I. Therefore, here is a AB matrix which is 11, 3, 7, 2, and here is a AB inverse, and this is the identity which is 1, 0, 0, 1. Okay. Now by the operation, here is a first is 2 times R1, we get, that is if you make it 2 times, then you will get 22. That is 22 minus, that is a R1, then R1 minus 3 times R2, then here we will get the 1. Therefore, we'll write here, that is a 2 times R1, we get here 22, 2 into 3, 6, 7, 2. And here is a AB inverse 2 times R1, that is a 1 into 2, 0, 0, 1. Okay. Next is by R1 minus 3 times R2, R1 minus 3 times R2. Here is a 22 minus 21, 1. Again 6, 3 into 2, 6, overall this will become 0. And next is a 7 and 2 is as it is. Here is a AB inverse. What about here? On this side, that is R1 minus 3 times R2. Therefore, first element is 2 is as it is, because this here is a 0. Next is 0 minus 1 into 3. That is a minus 3. And next is a, here is a 0 and 1. Now we can make this 7 as a 0. Therefore, by R2 minus 7 times R1, we get, here is a 1, 0. Therefore, 1 into 7, that is here is a 0. Next is 2 into AB inverse, and that's equals to R2 minus 7 times R1. Keep this 2 first row as it is. R2 minus 7 times R1, that is a 0. Here is a 0 minus 7 into 2. 0 minus 7 into 2. Therefore, here you will get minus 14. Next is 1 minus into minus 3. That is a, sorry, minus 7 into 3. That is a 21. 21 plus 1. That is a, here is a 22. That is R2 is 1. 7 into minus 3, 21. 1 plus 21, that is a 22. And last is by 1 upon 2 R2, we get 1, 0, 0, 1, AB inverse, that is equals to 2 minus 3. Next is a minus 7, 11. And therefore, here is a identity matrix, identity into AB inverse, that is equals to AB inverse. Therefore, AB inverse is equals to 2 minus 3. And next is a minus 7 and 11. Okay, this is the first one. Okay, we have the AB inverse. Now we'll find out the determinant of the matrix A. Here is the determinant of A. What is A? A is 2, 3, 1, 2. A is a, that is a 2, 3, 1, 2. Now the multiplication, 2 into 2, 4, minus 3, that is equals to 1, which is not equals to 0. Therefore, A inverse exists. A inverse exists. Now next is consider A into A inverse, that is equals to I. Here is A, that is 2, 3, 1, 2 into A inverse. I is identity here, which is 1, 0, 0, 1. And simply changing, that is by R12. By R12, because here will be the 1 and we get, because they convert this matrix into the identity, the first element must be 1, 1. Therefore, by the operation R12, we get here 1, 2. Okay, next is a 2, 3 into A inverse, and here is a 0, 1, 1, 0. Next, by R2 minus 2 times R1. R2 minus 2 times R1, we get R2 minus 2 times R1. Here we get, that is 1, 2. R2 minus 2 times R1, here is a 0, 3 minus 4 minus 1 into A inverse, and on this side 0 1. R2 minus 2 times R1, therefore this will be as it is, and 0 minus 2, therefore it is a minus 2. Okay, next is by minus 1 R2. By minus 1 R2 we get 1 2 0 1 into A inverse, and here is a 0 1 minus 1 and 2. Okay, minus 1 and 2. Now the next operation is a by R1 minus 2 times R2, then you will get here 1 0 0 1 into A inverse, that is equals to R1 minus 2 times R2, that is minus 1 into minus 2, for all that will become plus 2. Okay, 1 minus 2 into 2, that is a 1 minus 4, which is 1 minus 4 means what? Here is a minus 3, and last is a minus 1, and here is a 3. Okay, now this is the identity into A inverse, that is a A inverse is equals to A inverse is equal to 2 minus 3 minus 1 3. This is the A inverse. Now next is we'll find out the B inverse, but before that, determinant of B. Now what is the B matrix? Here is a B matrix 1 0 3 1 1 0 3 1 1 0 3 1. Next is 1 into 1 1 minus 0, that is equals to 1, and it is not equals to 0. Therefore B inverse exists. B inverse exists. Now consider B into B inverse, that is equals to I. Therefore here is a B. What is B? B is 1 0 and 3 1. 1 0 3 1 into B inverse 1 0 0 1. Okay, now the next operation is that is first element A11 is 1, already 1, therefore we will make here 0, that is by R2 minus 3 times R1, here is a 1 0 0 and 1. We get directly the identity. Now here is a 1 0. R2 minus 3 times R1, here is a minus 3 1. Okay, therefore the B inverse is equals to 1 0 minus 3 1 1 0 and minus 3, 1. This is the B inverse. Now we'll find out the product of B inverse into A inverse. Now here is a B inverse 1, 0, minus 3, 1. What about the next? A inverse. A inverse is, here is A inverse 2, minus 3, minus 1. Again by mistake, here is a, instead of 2, I write here 3. I am replacing here, that is a 2 and 2. Here is a inverse. Therefore, 2 minus 3 minus 1, 2. And now their product. Again here, the first row, first column, 2. First is 2. Second, first row, second column, minus 3. And next is a minus 6 and minus 1. Minus 7, plus 9 and plus 2, that is 11. Okay, this is, and this is the expression number 2. This is B inverse and A inverse. Therefore, what is the one here? The expression 1. This is 2 minus 3 minus 7, 11. This is 1. And this is a 2. Both are equal. Therefore, we will write here from 1 and 2, from 1 and 2, AB inverse is equals to, AB inverse is equals to B inverse into inverse, and hence it is a root. Here is a, first we will find out the determinant of A. Determinant of A is equals to, determinant of A is a 4, 5, 2, 1. Now their product, 1 into 4 minus 10, that is equals to minus 6, and that is not equals to 0. Therefore, A inverse exists. Okay, A inverse exists. Now consider A into A inverse, that is equals to I. A into A inverse, that is equals to I. Here A is 4, 5, 2, 1 into A inverse, and I is identity 1, 0, 0, 1. Okay. Now the first is by 1 upon 4 R1, then we get 1 upon 4 R1, then we get here is a 1, 5 upon 4, 2, 1 into A inverse. Again here 1 by 4, 0, 0, 1. Okay. Now the next is by R2 minus 2 times R1, 1, 5 by 4, here you will get 0, 1 minus 2 times 5 by 2 times 5 by 4 means what? 5 by 2. 1 minus 5 by 2. Therefore, here you will get 1 minus 5 by 2 means what? Here is a 3 by 2 into A inverse, and on this side that is 1 by 4, 0. R2 minus 2 times R1, that is a 0 minus 2 into 1 by 4, that is a 1 upon 2. Therefore, here is a minus 1 upon 2. Minus 1 upon 2. R2 minus 2 times R1, and this 1 will remain as it is because here is a 0. There is 0. Now the next is by the operation minus 2 by 3 to R2, that is by minus 2 upon 3 R2, we get here 1 5 by 4 0 1 into A inverse, and that is equals to 1 by 4 0. That is minus 2 by 3 into minus 1 upon 2, 2 will get cancelled, minus minus will become plus, and here is a 1 upon 3 minus 2 by 3, okay, minus 2 upon 3, okay. Now the next operation is a by R1 minus 5 by 4 R2, R1 minus 5 by 4 R2, therefore here is a 1 0 0 1 into A inverse, and that's equals to R1 minus 5 by 4 R2, that is a 1 by 4 minus 5 by 4 into 1 upon 3, that is a 5 by 12, that is here is 1 by 4 minus 5 by 12, and if we multiply here by 3, that is a 3 minus 5 upon 12, that is a minus 2 by 12, means what? Here is a minus 1 upon 6. Next is a 0, minus minus will become plus 2 by 3 into 5 by 4. Then we'll get here, that is a 5 upon 6. 5 upon 6, and last row is as it is, 1 upon 3 minus 2 upon 3, and this is the A inverse, and from this we can take, that is a 1 by 6 as a common, therefore A inverse is equals to 1 upon 6, and here is a minus 1 5, next is a 2, and here is a minus 4, minus 1 5 2 and minus 4. This is the first part. Now what about the next? That is a next side is, we want to do that. Here is a 1 by 6 A in bracket 5I, 1 by 6, which is the RHS. Now here is a RHS is 1 by 6 in bracket A minus 5I, and that's equals to 1 upon 6 in curly bracket, the first A matrix is 4 5 That is the matrix A 4 5 2 1. 4 5 2 1. It is a complete minus 5. Identity matrix 1 0 0 1, and here is it's completed. Therefore 1 upon 6. Now simplify this. We'll simplify here. That is 1 by 6. First is multiplication with 5. That is a 4 5 2 1. Multiplied with 5, then you will get 5 0 0 and 5. Curly bracket is completed. 1 by 6, and subtraction of these two matrices. 4 minus 5, that is a minus 1. 5 minus 0 is 5. 2 minus 0 is 2. 1 minus 5 minus 4. Okay, here is a 1 upon 6. 1 upon 6 minus 1, 5. That is 1 upon 6 in bracket A minus 5y. Okay, this is number 2, and therefore we say 1 by 6 minus 1 5 2. Okay, therefore from 1 and 2, from 1 and 2, A inverse is equals to 1 upon 6 A minus 5 I, and hence it is approved. Now in this way we have completed up to the example number 10. Now we'll see in the next video. Goodbye.